G'day guys, Socket here. Today we're going to continue on with our car audio amplifier series where we're looking at all things to do with amplifiers. Now, so far in the series we've looked at how electricity works, what terms like volts, amps and watts mean, how to use those things using Ohm's law to calculate stuff like amplifier power or speaker load, or the battery life, or your car battery life and stuff like that. So if you haven't already watched part 1 and 2, I encourage you to jump back and check those out, because it's got a lot of great valuable background information that will just help you as we dive deeper into this tutorial series. So in today's episode we're going to take a look at amplifier basics, why we need an amplifier, the basics of how they work, the different types of amplifiers, and some of the common misconceptions and myths surrounding amplifiers. So let's get going and get started on with part 3, amplifier basics. So let's talk about amplifiers, starting with the signal chain. Everything starts with a source, because your music needs to be coming from somewhere, right? So maybe you're using a head unit to play music, or maybe a phone or a digital player or whatever. But whatever source you're using, the music signal from that source needs to get to your speakers, so you can hear it playing, right? So this music signal coming from your source has a special name, and we call it a line level signal. But just to be confusing, sometimes it's called an input signal or a preamp signal, and it has a bunch of other names, but just to keep things simple, we'll just call it a line signal, and we'll come back to these other names later in the series. So the problem with this line signal is it's very weak, and it's far too weak to drive your speakers, right? So what I mean by that is it doesn't have enough power to move the cone of the speaker back and forward to generate generate noise or play music, right? It's just way too weak. So to drive our speakers to be able to move the cone back and forth and create music, we need to amplify this line level signal and provide the speaker with a sufficient power to be able to move, overcome the magnetic resistance and all of that stuff to make our speaker move in and out. And we sort of looked at this during the language of sound tutorial about how speakers speakers operate. So this is where an amplifier comes in, right? So let's have a look at a basic car audio setup where we're using the the head unit to drive a set of speakers. Right now, we all know that you can plug, or with some head units you can plug your speaker level wires to your speakers and play some music, right? So what we would do is connect the head unit to the speakers with some speaker wire. We turn on the head unit, and provided everything's sort of wired up, positive, negative, and all that type of stuff, we should be able to play music, right? So you'd look at this and you'd go, well, okay, I don't really need an amplifier. I can just hook up my speakers to my head unit and it's playing music. Well, no, that's not really the way it works, because in this system the signal, the line level signal, is still being amplified, but the amplifier is built into the car's head unit, right? So the line signal is both being generated and amplified in the head unit, and then it's being sent out as a high voltage signal called a speaker level signal, right? Now, not all head units have built-in amps. So if your head unit is just a head unit and it doesn't have an amplification circuit or anything like that, you won't be able to directly drive your speakers, right? Now, if it does have an amplifier circuit, happy days. But one of the main disadvantages of this setup is that most amplified head units are not very strong. Maybe 20, 30, 40 watts, maybe enough power to run maybe a couple of speakers, but even expensive models are limited in terms of their output and the number of speakers that they can drive, right? So, okay, so let's have a look at another type of setup, right? So this time, let's have a look at a DSP amp combo, right? Where we have, a DSP like a Helix V8 or something like that, that has a built-in amplifier. So it's a little bit like the head unit example, but in this case, the line signal from the source is going to be sent to the DSP, and the DSP is going to manipulate that line signal by, adding timing or, EQ filters and cuts and boosts and whatever else, and that signal is then going to be amplified by the DSP, right? And all that's happening in the DSP at once, right? But once again, the amplified signal is sent out to the speakers, as a speaker level signal via the speaker wires, and moves the speaker cone in and out, and plays music. And just like the head unit example, the amp in the DSP amp unit is not as powerful as a dedicated standalone amplifier, right? But these units have the advantage of being able to provide all the benefits of a DSP, EQ and timing and individual speaker controls and all of that stuff, as well as an amplifier all rolled into one unit. So they're an excellent choice when you're on a budget, or when you don't have a lot of space, and space is super important. So okay, let's have a look at another typical car audio setup. And this time, we're going to have a source and a dedicated DSP, and we're going to have one or more standalone amplifiers, right? And so in this case, the source is being sent, the line signal is being sent from the source to the DSP. The DSP is going to do all the usual EQ and time delays and other stuff that's designed to do, and then it's going to send that line signal to the amplifier to be amplified, right? And so the amplifier does its stuff, and the resulting speaker level signal gets sent to the speakers via the speaker wires, drives the speaker back and forth, and we hear some music, right? So the main advantage of this type of setup is that there's a bunch of flexibility in terms of control and power that you can send to individual speakers, right? You can change the number of speakers, you can increase the power level of the speakers, you can put in different types of speakers to play different roles. The trade-off, of course, is cost, space and complexity in terms of your audio system. But common setups include having one amp to drive all your speakers, and maybe another amp to drive your subwoofer, right? Or some crazy systems have individual amps for your tweeters and an individual amp for your mids and your mid bass, and they end up with 5 or 6 amplifiers for one car audio system. So there are lots of ways that you can use standalone amplifiers in your system. It really just depends on your budget and goals. So regardless of how your car is set up, there is an amplifier somewhere in your system. So if you're running the head unit to your speakers and you're running your speakers off your head unit, there's an amplifier in your head unit. Or, if you don't have standalone amplifiers and you're running it through a DSP amp combo, then the amplifier's, in your DSP amp combination unit. And, now if you're using this third method, where you have standalone amplifiers, well, of course, the amplifiers, at this stage. But without amplifiers somewhere in your car audio signal chain, your car audio system simply wouldn't work. Okay, so now that we know that all car audio systems require an amplifier somewhere in the signal chain, let's take a closer look at how this all works. And let's start with the speakers. Now, as I mentioned earlier, we covered how speakers work in the language of sound tutorial, but let's quickly go over it again. So when we apply a alternating current to a speaker's positive and negative terminals, we can get the speaker to move in and out using the coil and magnet to push and pull the cone, which creates sound waves. So when we have no power being applied to the speaker terminals, the speaker cone will just simply sit in its default position, without moving or doing anything. But as soon as we apply a positive voltage to the speaker terminals, the cone of the speaker will push out. So positive voltage, cone moves out. And if we apply a negative voltage, the opposite will happen. The cone will pull in, right? So by applying, a positive or a negative voltage, to the speaker terminals, we can create this rapid back and forth movement, a bit like we can see in the little video above, which makes the sound waves that we can hear. And with enough power, we can drive the speaker and make it to play sound, right? The bigger the speaker and the louder we want to play, the more power that we need. And we measure this power in the units called watts. Okay, so now we've talked about speakers, let's have a look at the other end of the signal chain, which is the source. And let's start off with the example of a microphone. Okay, so here's a microphone, it has a diaphragm inside it. And it's picking up, whatever it's recording, sound waves that's recording. And those sound waves are moving the diaphragm up and down, and it's generating a tiny electrical signal, right? And we call this a mic level output. Now, the energy levels involved, we've got 120 millivolts or 10 to 100 microamps, which translate to, up to 2 microwatts. I mean, these are super tiny levels of energy or power, and way too small to ever drive a speaker, right? And if we sort of step it up a level and have a look at your mobile phone, you've got a headphone output, something like that, which is driving some plug-in headphones or your earbuds or whatever you're using. Once again, the numbers are super small, right? 0.3 to 1 volts or 10 to 30 milliamps, which is 5 to 30 milliwatts of power, right? Something like that. Once again, probably strong enough to drive these, your tiny little headphones, but not for direct connection to speakers. And if I look at a third example, such as an unamplified Android head unit, once again, half to 4 volts, 1 milliamp, 1 to 5 milliwatts of power. These are line level outputs designed to feed a audio signal into a DSP or an amplifier or something like that, not strong enough to directly connect to your speakers, right? And if I look at a speaker and the power needs of a speaker, and I just use a single speaker, just one speaker, one 4 ohm speaker with 100 watts, right? Pretty small speaker in terms of things, and I want to run it just at half power, as I would need 50 watts of power, which would be 14 volts and 3.5 amps, right? So much bigger numbers than any of these little, source level signals can ever supply. And it's for this reason we kind of need an amplifier to amplify these signals to be able to drive your speaker. So now that we've got that out of the way, let's go and have a look at what an amplifier does. So first of all, there are 3 things that an amplifier does, and as its name suggests, the first one of those is to amplify an input signal. So take a very small line level signal and amplify it so that the signal has the voltage and amps and the power to actually drive your speakers. And we've talked about that before, right? The second thing that an amplifier does is to match the pattern of the input signal and sends that identical pattern to the speakers. And it's because the pulses or the dips and peaks in the signal, so the peaks are the positives, the dips are the negatives, and it's this combination or this pattern of negative and positive voltages that will move the speaker in a certain way and duplicate the music or the podcast or whatever it is that the head unit is sending through your audio system. Will sort of play that almost like a little record following the grooves in a record track, right? So that's the second thing an amplifier does. It copies or duplicates the input signal as an output signal for your speakers. The third thing that an amplifier does is it converts the car's power supply, or the direct current power supply, 12-volt battery power supply, or if you're running your car, the amplifier, the alternator at 13.8 volts or whatever it is, and converts that to a alternating current power supply. And this is important because speakers require an alternating current power supply to move in and out. If we just apply a direct current to a speaker, for example, the cone will move out and it won't move back in. Now, an alternating current supply is where the flow of electrical power is in one direction and then it switches and flows in the opposite direction, and it does this 50 to 60 times a second, right? And so, once again, that's another important role of the amplifiers, to do this direct current to alternating current conversion, so our speakers will play. So when you look at all of the things that an amplifier does, and you can pick these things up for a couple of $100. They amplify the signal, they copy and duplicate the signal, so your speakers will play what the source unit is transmitting, and also doing this power conversion thing. They're pretty amazing pieces of modern electrical engineering. Okay, so now that we've talked about what an amplifier does, let's look at the different types of amplifiers. Now, there are bunches of different types of amps, and in this series I'm going to be focusing on the standalone amplifiers rather than the inbuilt amps that you find in head units and DSPs and things, although I will do an episode specifically on inbuilt amps. But when we look at standalone amps, they come in like many different shapes, sizes and types, right? And one way of looking at amplifiers is by the number of channels that they have. For example, a single channel amplifier is often referred to as a monoblock. They're used for powering subwoofers. They sometimes have dual RCA outputs for bridging the output to a sub. But they're usually big, high wattage single channel amplifiers, specifically designed for power hungry speakers like subwoofers. But amplifiers also come in multiple channel formats, with 2 channels, 4 channels, 6, 8, they're all common formats. But multiple channel amps are like having 3 or 4 little amplifiers all in one unit, right? And so that you can control multiple speakers or multiple speaker pairs, right? So each channel can control one speaker and has a negative and a positive output. So if you want to drive 4 speakers, you need a 4-channel amplifier. Amplifiers also come in different power levels, right? Now, we're going to go into this in much more detail later in the series, but the power an amplifier can supply depends on its power rails and the amperage that the amp can handle, right? But all amps come in different sizes, right? They, from everything from 5,000 watt monsters to 50 watt compact versions, and pretty much everything sort of in between. And so we'll talk later about terms like peak power, RMS, watts per channel, and all of these other things to do with amplifier power. But for now, all we need to know is that amps come in different power levels. Right. The third way you can look at amplifiers is their class. Now, you might have heard of the term AB class or D class amplifiers. There are other formats as well, such as G and H class amps, and later we're going to talk about what makes an AB amp or a D class amp, and all of these different types and the pros and cons and things. But very quickly, an AB class amp is an analog unit. It processes the line signal using analog, and a D class amp is process the line signal using digital. And as a result, they have very different characteristics, right? They operate differently and their characteristics are different. So, in general, an AB class will be bigger, run hotter, use a lot more power. They're generally more expensive, but they have, superior playback quality. You can usually tell an AB class because it will have heat, fins or fans or other things to, heat sinks and things bolted to it to dissipate the extra heat that it produces. Whereas a D-class amplifier, on the other hand, is much more compact. It will use less power. It will generally produce very little heat, if any heat at all. They're generally cheaper to produce and to purchase, but they're not as good in terms of reproduction of the audio signal as an AB class amplifier. And you can usually tell a D class amp by its size and its lack of heat sinks. So amplifiers come in many different shapes and sizes, and we haven't even touched upon, bridgeable and single and dual, power rails and, and other versions and features that, are found in amplifiers. But once again, we're going to dive into all of those details and how they work and the pros and cons of each, later in this series. So now that we've looked at the different types of amplifiers, let's have a look at some of the myths and misconceptions, around amplifiers. And the first one I want to talk about is peak power versus RMS. So on the front of the amplifiers, you'll find 1000 watts or something, big letters, all over the front of the amplifier. And what people don't realize is that these peak power measurements are really pretty much useless and are really just there for marketing purposes to lure consumers in to buy their products. So what I mean by peak power is this line here is the maximum voltage rail that the amp can put out, and peak power is kind of like this point where the the signal will clip. Yes, it can produce 1000 watts, but for a fraction of a second before the signal clips and carries on, and you don't want to be running your amp at that level, and it couldn't run at that level for any sustained amount of time. So yes, it can produce 1000 watts, but it's not 1000 watts of practical power. What you really should be looking for is what they call the RMS, or the root mean squared value, power value for your amplifier. Now, root mean squared is the normal operating range of your amplifier. It's going to bounce around the center line, and occasionally you'll get a drum hit or a cymbal or something like that, which will cause a little spike. But 99% of the time it's going to be operating down here in the RMS area, right? So don't be fooled by peak power claims. Always go and check out your amplifier's RMS value. That's a far more important measure. Right, the second one I want to talk about is somehow Class D amplifiers are inferior to Class AB amplifiers. Now, I just talked about this briefly when we were looking at the different types of amplifiers, and yes, there is a difference between the duplication or the level of copying the line signal, peaks and troughs and all of that type of stuff. Where the AB class, almost perfectly replicates that, and the D class, will be 99%, because the digital action of a D class amp, creates an approximation of the line signal. But in terms of, playback quality and all that type of stuff, way back when D class amps were new, they had problems with distortion and switching and, and all of that type of stuff. And duplicating the signal, but this is much less of a problem in modern D class amps, and for, it's so much so that if you had people listening to a track played by, AB class amp in your car or a D class amp in your car, and you just said to them, what type of amp am I playing, most people wouldn't know, right? It's that close. But if budget, space, heat issues and things like that are important to you, then the D class amps are superior to AB class. So, don't dismiss D class amps as somehow a worthy or an inferior, little brother. Okay, the third thing I want to talk about is the gain knob on your amplifier, and how somehow turning up the gain makes your system louder. So, okay, we covered this in the gain setting tutorial, so if you want a detailed explanation, head over there and watch that video. But yes, the gain knob is basically a voltage calibration knob. Turning it up simply reduces the point at which your volume knob will hit 100%. So turning up the gain knob won't make your system louder, it will just make it clip sooner. The next one is a bit of a strange one. It's this belief that more watts equals better sound, right? So, once again, I'm not sure where this comes from, but it's kind of like saying bigger speakers will sound better. Now, there's a question of how big do my amps need to be in terms of output, and yes, some headroom is beneficial, so your amps don't have to work super hard, but that's a completely different topic. But having 500 watts per channel on a 10 watt speaker won't make them sound better. And once again, the next one is kind of in the same kind of bucket, where there's this belief that somehow bigger wires will equal a louder system, right? Once again, I'm not too sure, of its origin, because more power equals louder, which is of course true, but if you're supplying 100 watts through a 4 gauge wire, it will still be 100 watts if it's running through a 0 gauge wire, right? Now, this myth probably has to do with something, with people running large gauge wires for speakers, and while that won't necessarily hurt, it isn't necessary, and it's really just a waste of space and money, right? So pick the right size wire for your application, and you'll be perfectly okay. So the last myth is that price is a good guide of quality, and this should be an obvious one, but brands and pricing and all of that type of stuff makes it really hard for us to sort of let go of the concept that if I pay a lot of money for something, it must be good. But just like wine, food, speakers, a whole bunch of things, expensive doesn't necessarily mean that something is good. Now, I've come across no-name amplifiers from China, that cost $200 that honestly shocked me in terms of how good they are, that they would seriously outperform some of the big name brands that cost, thousands of dollars. Or, amplifiers with gold tip connectors and fancy, features with low, distortion numbers and stuff, only to find those amps having constant shutdown problems or glitches or channels that are dropping out and a whole range of things, right? So some people think that unless they've spent X dollars on an amplifier or a speaker that it can't be any good if it's doesn't cost this much money, right? But this is simply not true. So do your research, listen to different amplifiers, if you can. And don't be fooled by the marketing and the list of fancy features that are often put into the marketing stuff for your amplifiers along with their specs. Good isn't and doesn't need to be expensive. So guys, that is my six big myths around amplifiers. I'm not sure if you've heard of some of those before or whether you believe in some of those. I hope that, however, over the course of this series that you'll learn more about amplifiers, how they work, and you'll figure out why some of these myths just don't make sense. So there you go, guys. That brings us to the end of today's tutorial. And as I mentioned earlier, we're going to dive into a lot of detail around amplifiers, the differences between the different classes and how an AB amp versus a D class amp works, and a whole bunch of stuff. Today's episode was really just on amplifier basics, trying to keep it super high level and super simple, but we're quickly going to become a lot more technical as we get into the detail. So guys, I hope you enjoyed today's tutorial. I hope you got something out of it. as always, thank you so much for watching. If you've got any questions or comments, please feel free to drop them below. I'll get back to them as soon as I possibly can. Otherwise, guys, I will catch you in the next episode.